Today we're gonna have the reasoning on text and data. So it's gonna be the first class. And I'll try to show you the things, the topics that we are going to cover during our course. So you could kind of have an idea of what you are going to study. All right, so this section basically is called reasoning on text and data, but it's just the fancy way of telling logic. So let me write, okay, let's say reasoning on text. This is basically the same as telling the logic. And reasoning on data, this is the same way as statistics. So basically you're reasoning on statistical deductions. So let me write it here.
So statistics won't be included in the math part, solo in data, in the reasoning part.
Statistics is going to be the part of math, but it's also going to be the part of logic one. So you're going to have some problems where you're given the table or the histogram or the graph. And based on this graph, you have to evaluate which of the statements are true or which of the statements represent this graph. So in the logic and in math, both you're going to have statistics.
Okay, thanks.
All right. And we are going to start, let's say, our class with the propositional logic, where basically we're going to cover the statements, we're going to cover negations, we're going to see the truth table, then we are going to cover the complex statements. Basically, anytime you have complex statements, you have to connect them, and we are going to do it while using conjunctions. And disjunctions. This is just the fancy way of telling or and and connectors. Then we are gonna cover the syllogism. So let me write, this is another thing. And in detail, we're gonna see the words like all, every, each, none, at least, and some. Again, in the syllogism, we are going to use negation as well. So we are going to negate the syllogisms. And then here, basically, you're going to start deductive reasoning. So once you did it, we are going to go to implications. Basically, this is the if-then conditions, right? I mean, while you're learning English, most probably you were studying the if conditions, right? So basically in logic, we are going to use if conditions in order to interpret them like in a logical way, and in order to work with them. So let me write if, then, and then we're of course going to build a truth table for if and then conditions. Then right away after studying if-then conditions, there are two more conditions, which is called necessary and sufficient conditions. Basically, it's just the, let's say, necessary and so necessary and sufficient conditions basically you could represent in conditional statements, and we are going to see how to kind of convert if-then to necessary and to sufficient. So while doing it, we're going to also see the proportions. you're going to see the ratio. So usually proportions, ratio problems comes also with percentage problems, probability, combinatorics, and so on and so forth. So these are like another topic. So once we've done it, we are going to see also the sets. So numerical reasoning, and then we are going to cover statistics. We're going to see statistics in math as well. So we are going to basically understand how to figure out the data from the graph, from the table, from the histograms, and so on and so forth. And then we'll talk about mathematical language, basically symbols. Usually in logic, let's say you have a statement. It's really convenient to represent the statement in symbols in a mathematical way in order to solve them, in order to work with them. And I'm going to teach you how to convert, let's say, sentences to the symbols. So it's kind of an easier work with symbols rather than statements and sentences. All right, and all of it will take around 8 classes. So you're gonna cover everything. So don't worry about it. You think that it's a lot, but you're gonna do it. So in today's class, let me write, that's the first class. You're gonna see the statement. Gonna see the negation. You're gonna build a truth table. We're gonna work with conjunction and disjunction. And we're gonna cover a little bit of syllogisms. And like to finish all it up, to wrap it all up, we are gonna see the DeMorgan's law. Basically, is the summarization of everything that we are studied. We'll summarize it by DeMorgan's law. Okay, let's start with statement. So usually in logic, every statement should have value. So this value could be true or false. So basically, you have a sentence. A sentence is a bunch of words connected together that have a meaning, right? But what's the difference between sentence and statement? Basically, statement is the sentence that could have two values, like first one, which is true, and the second one, which is false. So if you try to rewrite it, let's say show it in a relation of Venn diagram, it will be something like this. Let's imagine this big circle is the sentences, and the smaller one are the statements. All right, so for example, if I give you this statement, let's say all cats live on Mars. So what do you think, which value is going to take? It's going to be true or false? I mean, according to what I know, I can say that this is false, that not all cats live on Mars. I've seen a cat which lives on Earth, so that's why I could say that this one is false, right? For example, if I tell you the Earth is round. So this is the statement. So it's going to be true or false?
True.
Yeah, it's going to be true. For example, maybe if I come to you with this statement, let's say 2000 years ago, you couldn't answer for this, right? Because like 2000 years ago, people believed that the earth was like flat. It was not round back then. So um, these are the statements, basically the sentences that could have values, which is true or false, right? Yeah. The second thing we are going to talk is about negations. So negations means you basically have to take the opposite of the statement to negate it. Basically, you have to add not. For example, again, if I have this statement, all cats live on Mars, right? I'm going to write it here. And usually in logic, if you have a statement, you could denote it. You could give a value to it. You could write, so I'm denoting this whole statement as my symbol A, let's say, right? And you know that your A is false. So now I ask you, how could you negate the A? Usually the sign of negation, sometimes they use this one, sometimes they use this one, and sometimes they write bar on top of the statement. Let's say if you have A, you write bar on top of the statement. So like in this course, I'm going to use this one. So it's kind of a convenient one. So basically this stands for not. For example, here I have my statement A, and if I told you negate the A, basically I'm telling you to adjust not. So what's going to be not A? What's going to be the value of not A if A itself was false? What do you think?
True.
Yeah, it will be true. So since false and truth is just a binary word, right? If you don't have one, you have another one. For example, if you have false, negation of false basically tells you opposite of false is going to be true. And then if you have true, the opposite of true is going to be false. Okay, good. But what's going to happen if I do double negation? So what if I do like this, not A? What you're going to have?
False.
Yeah,
False.
you're gonna come back to your false again. So just try to remember in logic, anytime you double negate the things, you're coming to the original statement. So your original statement was false, and if you negate it, it becomes true. And if you double negate it, it becomes false. Just try to remember double negation, basically, you can cancel two nots, right? Okay, so this statement with only one negation, it was not all cats live on Mars. But how would you add the second negation? So this one was your not A, right? So that was not A. Because this one was your A. How would you represent not A? Which word you should add? Would you tell me not all cats live on Mars? It sounds strange, right? What could you write at the beginning of the statement? Try to think about it.
Some.
Every.
Not really. You have to tell me that this statement is false, right? How would you tell me?
What
Basically,
statement? The second or the first?
Look,
So
not all cats live on Mars. You have to adjust one more negation. You have to tell me what's the not a, like in representing the words, right?
Maybe we can add not all cats don't live on Mars or something like that.
Maybe, yep, that's the one way to do it, right? Another way to do it, what you could do is you could just add at the beginning, it is false that, right? So if you write it is false that, basically this part is the same as not, is the same as negation. And then you continue your statement. What was not A? Not A was not all cats live on Mars, right? So if you write it is false that, let me write not all cats live on Mars. So in this case, basically this negation and this negation will cancel each other. So basically, it is false that not all cats live on Mars. This is the same as telling that all cats live on Mars, because you are taking opposite of it, right? So finally, we'll have just your initial statement. All cats live on Mars. Okay, sometimes it could be something like this. It is false that, or they could use another word. They could write it is not true that. But it has the same meaning. It's still the negation, because false, this is the same as not true, right? So that was another way to adjust the second negation. Okay, good. Now, let's try to talk about complex statements, right? Usually the complex statements are the statements that contain, like, in itself, it has 2 parts or 3 parts and 4 parts and so on and so forth, but they are connecting with some connectors. So these are the conjunction and disjunction. For example, let's imagine A is a statement, right? It's some statement. You just write it. A equals to some statement. And then you have B, which is also another statement, right? And in order to make a complex statement, what you do, you have to connect A and you have to connect B. So there are 2 ways to connect it, via conjunction and via disjunction. Conjunction is the same as telling or. Disjunction is the same as telling and. So the first way to connect 2 statements usually is A or B. The second way you can connect A and B, right? So now the overall statement A or B could be true or could be false, right? It could be true or it could be false. The same for A and B. It could be true or it could be false. Okay, I'll talk in detail for each of them. Let's start with A and B. So A and B. Okay, usually anytime you have and, right, the overall statement is going to be true only if both of the statements are true. So it says A and B is true only if it's true when the A is true and when the B is true, right? So when the left side is true and when the right side is true, only in this case, A and B is going to be true. Let's build a truth table for it. So let's imagine A, B, and A, and B. Just try to remember that A is the statement itself, separate statement, and B is the separate statement itself. Here is my question. How many different cases we could have here? If you arrange A true, A false, or B true, B false, how many different cases we're going to come up with?
4.
Yes, it's going to be 4. So just give me a moment. Kind of trying to write it here, like true, B true. Usually anytime you're building a truth table, the first case is always where your left side and your right side is true. The second case is where your left side is true, but your right side is false. And then the third case is vice versa. You swap it. Your first false, and the second is true. And the last case where the both sides are false, right? Okay, according to this, according to the definition of A and B, when is going to be true? Like in how many cases out of 4?
First only.
Only in the first one, exactly. So it's going to be true only if the left side and the right side are both true, right? In this case, where your left side is true, but your right side is false, what's going to be? It's going to be false, right?
False.
Yeah. And in this case, it's going to be false as well. And in the last case, it's going to be false. Because in order to A and B to be true, your left and right side should be both true. So, but when you have A or B, so A or B is true when you have at least one of two sides is true. So in order to make A or B true, for us, it's enough to have one truth. Okay, if you have two of them true is also good, but at least one of them should be true in order to make the overall statement true. And if you try to build it, it's going to be A, it's going to be B, it's going to be A or B. And again, the first case where your A is true, your B is true, what's going to be your A or B?
True.
Yeah, it's going to be true because for us it's enough to have at least one, but here we have two, it's good. The second case where your A is true, but your B is false. What's going to be the value of A or B?
Still true.
It will be true. It will be true because for us it's enough to have at least one. We have at least one, which is A, right? So it's true. The third case where you have F and then truth, what's going to be the value?
True.
It's going to be true. And the last case where your left side and your right side is false.
It will be false.
Yes. So try to remember this one. A or B, it's going to be false only in one case, where the left side and the right side are both false, right? Okay, so in order to make it clear, I'm just going to give you an example with both with A and B and A or B, just for you to see the difference. Let's start with A and B. Let's imagine we have this statement. I will go Okay, then we start with or. So let's imagine the overall statement. Let's say overall statement it's gonna be our Q, right? And we have to figure out when our Q is true, right? And you could kind of imagine that Mario goes, this is your A, and Anna goes, this is your B. Okay, this problem tells you have to figure out when I go to the cinema, right? And we have 4 different cases, right? When the Mario goes, when the Anna goes, this is the first case. When the Mario doesn't go, but the Anna goes, this is the second case, and so on and so forth, right? Let's imagine this case where we are in the first case where the Mario is true and Anna is true. So basically where your A is true and B is true, meaning that Mario goes to the cinema, Anna also goes to the cinema. So in this case, will I go to the cinema? Will my Q overall be true? Yeah, it's gonna be true, right? It's gonna be true in the first case. So what if we are considering the second case? Like this. Let's imagine Mario goes to the cinema, but Anna doesn't go. Will I go in this case to the cinema?
Yes.
Yes, I'm going to go because for me, it's enough to have at least one friend who goes with me, right? Definition of or is basically to have at least one. Then we have the second case, the third case actually, where Mario doesn't go, but Anna goes. Will I go to the cinema in this case?
Yes.
Yeah, I will go because I have at least one of friends who are going with me. And the last case, let's imagine where both Mario and Anna doesn't go to the cinema. Will I go to the cinema in this case?
No.
No, exactly. In this case, I will not go to the cinema because I need to have at least one of the friends who goes with me. So, but what happens if we change or for and? So let me write it and let me clear.
Only the first will be true.
Only the first case, right? Where you have 2 friends that are going. So the first case is where Mario true and the Anna true, basically meaning that Mario goes to the cinema and Anna also goes to the cinema. So in the case of and, I will go to the cinema only in one case, where both of my friends are going with me. So all different cases, I will not go, only in one case. So let me write true, and all the other cases are going to be falses, right? So you see, when you have or, you have 3 possibilities that your statement could be true. When you have and, you have only one possibility that your statement could be true. All right. So let me just try to see. You're covering everything. Okay, good, good. So the next thing is to understand what is the DeMorgan's law. Have you ever heard about it before? Not really, right? So like seems something, I don't know, something hard, but basically DeMorgan's law is the law of negation of complex statements, right? So usually complex statements are the statements that are connected with disjunction or conjunction. And DeMorgan's law basically gives you the rule how you should negate the complex statement. For example, let's imagine we have the complex statement A that is connected with and then we have B, right? So let's imagine this case. Basically, DeMorgan's law tells you have to negate this statement. Since this is the complex statement, you have to take parentheses and you have to negate. You have to add not. You have to distribute this not sign into the brackets, right? And what do you think? What's going to equal to this one? Like your ideas.
We'll replace and or.
Can you repeat? You said and becomes or?
Yeah.
It is actually true. So you could kind of imagine it as, let's imagine this is the multiplication and there is some value. So you have to multiply this value for the first variable, you have to multiply this value for the second variable. So basically, this is the mass distribution problem rule. And you also have to distribute not sign to the end. So it's going to be not A, it's going to be not B, and then it's going to be not and, right? It's going to be not and. And actually in logic, not and has the same meaning as or. So instead of not and, you write or. And this is the DeMorgan's law, by the way. So let me write, this is the first. When you are negating complex statement with and. So the second one is when you're negating the complex statement with or. So let me write the second case where you have A, and then you've got or B. So guys, what do you think? What's gonna have in this case? What we're gonna have here?
And bây giờ thì
Right? Not or becomes and. So I'll write and between them, and basically we negate the first and the second variable. So it will be not A or B. All right, why this works? So we're gonna right now see why this works by kind of trying to prove it by truth table. So we're gonna build a truth table for the first one, and we're gonna see that this actually works for both of them. And yeah, for this, I guess I need a table. So let me try to build a table. Okay, it's a little bit big truth table, but it's not hard. So let us fill it. Fill these values. So you have A, you have B. Anytime I'm writing A and B, you have to imagine that A is just some statement and B is just some statement, right? Then the first one, we're gonna have A and B. So let me write it smaller, A and then you're gonna have not A and B. So maybe I'll make it bigger. Then you're gonna have not A, not B, and not A or not B. All right. So let's consider the first case. Usually always the first case where your left side and right side is true. So your A and B is true. What's going to be the A and B?
Oh,
true.
Is going to be true. What about not A and B?
False.
Yes,
False.
basically it's the opposite of A and B, which is false. What about not A?
False.
False.
Yes. What about not B?
Also
False.
false.
Right.
False.
Not A or not B.
False.
Okay, why it's going to be false? This one.
Because not A and not B, both of them false.
Yes, in order to make or true, we need at least one true, right? But in this case,
Yes.
them are false. Good. All right. Just, you have to compare the values. So do remember that this one basically is the left side, right? I'm kind of try to make a connection here. Basically, this one is the same as this column. And this one is the same as this column, right? So this law says that this one has equivalent truth value as this one, right? And now you have to compare their values. So in the first case, you have not A and B is false, and actually not A or not B is also false. maybe this is the luck, maybe this is just a random case, right? Let's try to fill it, fully and then really make a conclusion from it. So the second case, you're gonna have A true, B false. What's gonna be A and B?
False.
Yep, great. What's gonna be not A and B?
True.
Or not?
True.
What about not A
False.
and not B?
True.
Exactly. And what about not A or not B?
True.
Not really false. It's gonna be true.
True. True.
Yeah, it's gonna be
True.
true because we need at least one truth. And in this case, we have. Maybe again, this is the luck that they are the same, right? So we just continue fill it up. The third case, you have this one. So here again, you're gonna have false because A and B is only true in one case, and we already had this case. Basically, this one is opposite, is true, and then this one, the opposite of F, which is true, and another one is the opposite of true, which is false. In this case, not A or not B is gonna be true. Okay, again, you see that this one is equal to this one. And the last case where the both are false, so your A and B is gonna be false, and then opposite of false is gonna be true, and then it's gonna be true and true, right? Opposite of false, false, true, true, and basically OR of true, true is gonna be true. And here you see that every entry of this column is the same as every entry of this column. It means that basically this one, so let me write it like this green. So this one has the same value as this one. That's why they are equal to each other, right? You see it? Okay, so here is the assignment number 1. Or I'm right, homework. Okay, try to build the truth table in order to prove the second case. So basically this truth table proved the first relationship, but you have to build the truth table for this one. So in order to do it, basically here you're gonna have, instead of and, you're gonna have or, and here instead of not A and B, you're gonna have not A or B. And at the end you have not A and not B. So you just kind of swap the entries, and yeah, you have to fill it. All right. I guess we are ready to solve some problems. Yeah, let me see if I have some. I think they are here. This is a little bit bad quality picture of the problem, but please let me know, can you read it? Is it readable? If not, I'm gonna rewrite it.
After rainy and
Windy, right?
Mm-hmm.
You can read it, right? Or not?
Yeah, a little bit.
Okay, then try to solve this problem. So basically the problem asks you that you have the statement and you have to find the equivalent statement, like what this statement means, right? And just try to recall that anytime you have something, it is not true, basically means that you have negation, right? And for example, this one, that it's rainy or windy, this is your statement, and you have to negate the statement. Try to figure out which of the values, which of the choices is correct. Only one should be correct. I'll give you 2 minutes. Camila, try to recall when you negate. You don't have to negate only the values, but you also have to negate the connector, right? So if it was and, you have to negate and as well. All right, I received 6 answers out of 7. So I guess we're good to start to solve it together. Yeah, most of you answered correct. Great. That's really encouraging, by the way. So in this problem, it is not true that it is rainy and windy. So I rewrote it here. Basically, it's the same as telling not. You have to negate the statement. Basically, the word, it is not true that. This is the same as negation, right? So at the end, what you've got it is rainy and windy. And then you have to negate the statement. And then since this is a complex statement, basically it's connected with the connector and. And what you've got here, you've got your A, and then you've got your B. So basically this is the same as writing not A and B. And according to DeMorgan's law, what we actually proved, this is the same as telling not A or not B. And not A or not B, if you again convert to the language, to the words, it will be that it is not rainy or it is not windy, right? So basically this one here stands for not. So the original statement was A, it is windy. Not A will be it is not windy, basically the opposite one. It is not rainy or it is not windy. All right, the right answer is A. It is not rainy or it is not windy. All right, I'll give you the second problem. It's a little bit more harder than the first one, but basically it covers the same thing. Here you have your statement. T is a right isosceles triangle. And it says then the negation of the statement. So basically it's this, you have to negate the statement. And what's going to be your final statement? What's going to be your final result of it? In order to do it, we just have to understand what's the right and what's the isosceles triangle. So I'll just remind you a little bit of geometry. So the right triangle, when the triangle has the 90-degree angle, right? So this is the right triangle. Right. Okay, what means isosceles triangle? Do you guys remember from the geometry?
Two sides are equal.
Yes, 2 sides and 2 angles are equal, right? So, for example, you have this kind of triangle, and it says it's isosceles, means that these 2 sides and also these 2 angles are equal, right? But in this problem, it says your triangle at the same time, right, and isosceles. Basically, they are hiding the end, but it is there actually, according to the context. So let's imagine we have this triangle, which is right, and which is also like these 2 sides are equal to each other. That's why this is the right and isosceles triangle. So then we have this statement, T is your right and isosceles triangle, and you have to negate it, right? So you're right. Let's imagine that's your A and your isosceles. This is your B. And basically what you've got not A and B. So according to DeMorgan's law, it's going to be the same as not A. Basically, you contribute not to and as well, and not and becomes or, and then not B. And again, you have to convert it to the words, right? You have to return the words. So if your A was a right triangle, what's going to be your not A? It's going to be not right triangle, right? So then you write not right, and then you write or. And if your B was isosceles triangle, not B will be not isosceles triangle. So basically this sign is the same as not. All right, and this is the answer, by the way. So let's see if you've got it. T is not right, and it is not isosceles. The A seems correct, but this is actually not, because instead of and should be or, right? So that's why A is wrong. B, it is isosceles, but not right triangle. Basically, it says it is A, but not B. T is a right triangle, but not isosceles. This one vice versa. It says it's B, but not A. Is not a right triangle. T is not a right triangle. Or, okay, here's the answer, E. It says not A or not B. All right, any questions here? So far, so good. All right, no questions. We could continue.